Hey everyone, welcome to Fab Forge 5. I'm glad you're here. We're your friendly, full-service neighborhood invention shop. And we design and build fun and unusual things, and we always learn something new along the way, whether we want to or not. And in this case, we're going to have to learn something new. So we're in the middle of building this neat little mint tin CNC plotter, our mini drawing robot. It looks like this. We designed it in Fusion 360. And the biggest criteria for this thing is that it needs to be totally self-contained. It doesn't require an external computer, runs on batteries, and fits inside a little mint tin. So when you open the tin, it starts drawing something for you. Big goals. We achieved most of that. I mean, it's self-contained. I don't need a computer now. It is battery powered, and we'll talk about the power this thing needs and the batteries that we have to use to make it work. It does fit inside our tin. It starts trying to draw when you open it up, but small problem. It doesn't draw because it can't push down hard enough on a pencil lead down on a piece of paper to make it actually draw something. Small problem. So at this point, when I'm working on a project, there's kind of a couple of options. I never give up, but sometimes I set a project aside and work on something different until I can find some different technology, some different approach, some kind of inspiration that helps me get over whatever block I'm having. But I've invested a lot of time in this little plotter, and I have a big goal. I want it to draw a sketch of the Millennium Falcon, and right now it's just not going to do that. Oh, we also have some software issues to solve, but I think I know how to do that too. So I'm not going to stop. I'm going to keep working on this. But we have to find a new method to draw on paper. I do have an idea, so we'll give it a shot. So come along for the ride. Let's see what we can figure out, and let's get started.
Fab Forge 5.
All right, so I think I described our problem. This thing actually moves around. Like, the mechanics of it work. We have some software issues to solve, but as you can see in this little window here, as it's moving, it's not drawing anything because it can't push down hard enough on the paper. I should have realized this. It's just a simple physics, statics problem that I didn't think about properly. But I think I have a solution. So the trick is we have to have some type of drawing mechanism that requires almost no pressure on a piece of paper. If you think about something like a paintbrush, that's kind of an example of that. Even a Sharpie marker doesn't really require a lot of pressure to work. It's just letting the ink flow out as it moves along the paper. The problem with both of those is we have to have this thing sitting inside a closed mint tin for we don't know how long, and then when the person opens it up, it has to start drawing. So it can't go have you dip a paintbrush in some paint. It can't have you put a giant Sharpie on it where you've just taken the cap off. And so it all has to fit inside a little tin. And so things like that will not work. What would work? I gave a lot of thought to different types of ways to draw on paper. And here's my idea. Let's see if it works. I'm glad you're here. I'm using a soldering iron and some thermal paper, and you'll see why. But what's happening here is, here's our pulleys. So this is a side view. Here are our pulleys. Here's our drawing surface. And here's our little carriage or shuttle with the pencil lead going through it. And then we've got these belts that go up like this and wrap around the pulleys. So the problem is we've got a lot of force going this direction on these belts, and that's great. But if you work out the geometries and the forces and the static forces, basically, you'll find out that the force going downward, because this belt is pulled so tight, is very small. So it can be large this way, but when the angle is so flat, it's small vertically. That's our problem. If it was something like this, where we had a big force here, big force here, the force here would be a little bit better, but it's not, and we can't really fix that in any easy way. So the reason I'm using thermal paper here is because I had a new idea. So my soldering iron, this thermal paper is the stuff that, you know, cash registers use, gas station printers, stuff like that. So it just changes color based on heat, and it actually works really well. And so right now my soldering iron is set at a temperature of about 300 degrees Fahrenheit, and it works really nice. So I want to put a little thermal heat thing right here instead of the pencil lead. And it won't need any force to push down hard. It can just rest on the paper and draw. There's a persistent fly flying around the garage here, and it'll draw some nice, you know, some nice lines and stuff for us. So I think that's the trick. So I'm going to take our little shuttle or carriage, whatever you want to call it, take out the pencil lead, and instead make some kind of a little coil of Nichrome wire, which is that kind of wire that heats up and turns, you know, red or orange when some current goes through it. And then I'll have two leads coming out, connecting to some wires. And then instead of having our servo lift up and down each time we wanted to lift the pencil lead off the paper, we'll just turn our little Nichrome wire coil on or off. So it'll be always resting against the paper, but it'll be turning on and off to draw lines for us. Actually, the mechanism for that is a lot simpler. The trick is now we have to have two wires going to our carriage, but we can figure that out. So now what we have to do is figure out how to power our little Nichrome wire coil, make it hot enough to draw on the paper, and also make it so that it can turn off and on pretty fast as the carriage, you know, moves around, making lines or not making lines. So hopefully it can do stuff like this. So let's do some experimentation. We'll go back to the drawing board with our Arduino and some breadboards and see if we can get this all figured out. And then we'll put that on our plotter and see if it works better. So that's the plan. Doing a bit of research here on Nichrome wire, I settled on 36 gauge Nichrome wire, which will produce 400 degrees Fahrenheit at 0.38 amps or 380 milliamps. That's actually a lot of current, but with the right batteries, we can easily handle that. So let's grab some 36 gauge Nichrome wire and see if we can fashion a little drawing mechanism. All right, here's our Nichrome wire. I fashioned it into kind of a point, and then I inserted it into the little shuttle using some high temperature RTV silicone, which is used for making gaskets for engines. It can handle up to 600 degrees Fahrenheit, so that should be a perfect way to hold it in place. And yeah, we should be good to go. Let's give it a test. But first we need to redo our design in Fusion 360. We have to take out the servo and make some room for some electronics to drive the Nichrome wire. Here's our original design in Fusion 360. So this is our servo that moves the Z slide up and down, which isn't working. So, well, it does work, it moves up and down, but the pencil lead doesn't push hard enough on the paper, so that doesn't work. So we need to completely redo this. And here is the new idea. So now, getting rid of the servo, getting rid of the Z slide, I put a little spacer in here to mount a little perf board on. And then we'll build our driver circuit for our little Nichrome heater on this perf board. And then on top of that sits our SD card reader, just like before. So that's how it looks now. So we actually saved some space, got rid of a servo, but we got to build a little driver circuit for our Nichrome heater. But it all goes together like that. I'm feeling good about this. Let's give it a try. We'll use pulse width modulation with the Arduino to power our Nichrome heater. So pulse width modulation basically generates pulses of different widths to make an apparent power at whatever you're trying to drive. It turns out that if we use about a 35% pulse width modulation, it will look to our Nichrome wire like we're providing it with 0.38 amps. So to create that high of an amperage, we can't provide that directly from an Arduino. We'll actually use our Arduino to drive a power transistor, a Darlington transistor. I picked the TIP 120. It's easy to find, cheap, been around for a long time. It can handle up to 60 volts at 8 amps, which is a lot more than we need. It actually responds really fast as well. So basically, the Arduino will output a set of pulses at a 35% duty cycle, which our TIP 120 will then use as a on-off switch, basically, to switch 380 milliamps for us to run through our Nichrome heater. Yeah, it seems a little bit complicated, but it's actually pretty simple in practice, and it should work just fine. It'll protect our Arduino from too much current, and it's a small amount of current compared to what the transistor can handle. So we'll get that all together, build that on our little perf board that fits inside our slot where our servo was, and give it a shot. Yes. All right, so this should be a 1 centimeter square. Is it? No. It's about half that size, but that's a scaling problem. I can fix that. At least the thermal idea works with the batteries I have. So that's some big news. Just got to get this thing kind of squared away a little better now, but I'm excited. Success. To fix the scaling issue, I ran into a bunch of different programming problems. All my fault, basically, about setting variables wrong, but finally ended up with a nice 1 centimeter square. Not exactly square, but I'll take it. When the heater's on and the stepper motors are moving, the overall system draws about 0.8 amps, 800 milliamps. So I'm using special lithium AAA batteries to provide that type of current. Let's draw something a little bit different here, a little bit more complex with some curves in it. We'll see if we can make a heart. And here we go, it is working. Now it pulls itself up off the paper right here because the wires are so stiff, but the heater's working. To fix the wire, I got some nice flexible silicone wire. It's used for wearable electronics. Nice and flexible. So I replaced that wire. Let's try again with a different type of sketch. Here's a quick look at Gcode. That's kind of important since our mini robot plotter runs on Gcode. And a Gcode gets generated from different types of ways. You can have a different application that takes a sketch or a 3D model, etc., and generates Gcode from that. Pretty simple, lots of ways to do it, but I want to talk about what Gcode looks like because it is important. So here's a Gcode file. Anything that has a semicolon is just a comment. So here's a 10 millimeter square. And there are different types of commands. There's G commands, there's M commands, and a few others, but we'll focus on what's here. So here's a G28 command. That's just auto home. That's the first command that happens. It makes our plotter home itself using the 2 limit switches, which you've seen, and then it readies itself to actually do a sketch. G90, absolute programming, means that every dimension that we're showing or every coordinate is relative to 0. So once it's homed itself, that's its 0 location, and then all the different coordinates it gets after that depends on that 0 location. A few other things here. Anytime you see a Z of 135, So the z-axis is where you might lift up a tool or lower a tool. In our case, the z-axis is whether we turn our plotter or our drawing on or off. So a Z135, that's left over from when I had the servo back in the first iteration of this. Angle number 135 would lift up the whole drawing apparatus, and that would turn the drawing off, or that's what I thought. And then Z175 would lower the servo, but in our case, I just stuck with those two numbers. So 135 turns off the drawing, 175 turns it on. And then we've got something here, an M6, a tool change, tool number 0. In our case, we only have one tool. We just have our one drawing apparatus. But if we had something more complicated, like a multicolored plotter, for example, that might be where we change from red to green, etc. And it might prompt us for that. But in our case, we just basically ignore that. So the first thing is we set our feed rate to 100 millimeters per second. I think the A is our acceleration. We don't really care much about that. And we'll set our starting location at X minus 5 millimeters and Y 5 millimeters. That's where we'll start drawing our square. Then we'll turn on our heater to start drawing on the paper, and then we'll start moving. So we'll move to X5, Y5, then we'll move to X5, Y minus 5, etc. And if you think about this, you'll see that what we're doing here is moving in a square, a square movement type scenario where we're drawing a square. And then we'll turn off our little heater to stop drawing. And then we'll move out of the way a bit. We'll move to X0 and Y minus 10 to move out of the way a bit so we can see the sketch. And also because that minimizes the overall force on the spring. This could be sitting, for a long time inside the tin. I don't want the spring to lose its memory. And so this takes a bit of the force off the spring. But pretty simple, that's how Gcode works. So it's just a series of movements and turning the drawing on and off. Now if we look at something like the Gcode for a Millennium Falcon sketch, obviously it's a lot longer. Still have the same thing that we home it. We tell it that it's relative to 0, 0, and we start giving it commands. And so in this case, we're going to turn off the plotting, come down here, move to a certain place, turn it on, and start drawing. Now, if you think about a sketch of something really complicated, you're going to be drawing lots of little short lines. And so if you look at this, there are lots of times where it turns off the plotting, moves to a new place, turns it back on. Draws a little line, turns it off, moves somewhere, turns it back on. So that's what's happening here. Lots of on and off, moving around, but it should draw a bunch of little lines that ultimately draws a Millennium Falcon. Will it work? That's the big question. It doesn't matter how long the Gcode is. This could be a long, long program. That doesn't matter. It will fit on the SD card, and our plotter will just follow that one step at a time. The only issue there is, will it fit on the paper? That's kind of the only limitation we have. But that's Gcode, pretty simple. Let's give it a shot. All right, it worked. So I'm pretty happy with this. You can see a couple little things though. There are some smears on this sketch where the heater got turned off, but it was still cooling down as it was moving, and so it caused some stretched lines on there. We can easily fix that by adding a little pause to wait for the heater to cool off before it moves to the next spot. You can see about 2 or 3 of those, but that's easy to fix. That's just a quick software update. So yeah, it works. We succeeded. So I'm actually pretty surprised and pretty happy about this. This was a big project and a big goal, and when I started it, I had this vision of how I wanted it to work, and I really had no idea if it was possible. And along the way, we had a bunch of challenges we had to solve, but we did solve them, and we were able to sketch the Millennium Falcon with our little mint tin CNC plotter, our mini drawing robot. So I'm pretty happy about this. The nice thing is it can literally draw anything. All we have to do is create the Gcode, pop it in a little SD card into the little mini plotter, and it will draw it for us. I've tried a few things that are really complex, and it gets complicated because it just takes a long time. The Millennium Falcon takes about 10 minutes to sketch, but that's okay. It actually worked out pretty well, and I'm happy about it. So we're going to declare success and have some fun with this now. I'm going to try different things, different ways of plotting stuff. Might try some different tweaks to make it faster, maybe use a little bit less current from the batteries. But what I found is, even though it's still battery powered, the batteries, if you use the right ones, they can run this thing a lot. I've done maybe 10, 12 plots so far on one set of batteries, and they're still running strong, so I'm happy about that. So thanks for joining me on this ride. It's been kind of a tough one, but we're going to declare success here. I hope you enjoyed it. Please like this video and subscribe. I do lots of things like this. The next one's going to be something totally different. I think we're going to try to make an artificial nose using machine learning so it can learn how to identify different substances, like maybe wine versus whiskey, dark chocolate versus milk chocolate, I don't know, peanut butter versus jelly. We'll see what we can figure out. But yeah, subscribe. I'll let you know when that's ready. It shouldn't take too long. We'll have some fun with that. We'll definitely learn something new, and I'm glad you joined us. So until I see you again, take good care of each other, have some fun, and I'll catch you later. Bye.